Welcome to the deep dive. We are, I think it's safe to say, officially past the era where AI was just a novelty or, a sophisticated chatbot.
Oh, for sure. We're now firmly planted in the age of the autonomous AI agent.
Exactly, an entity that's sophisticated enough not just to understand a complex goal, but to, well, dynamically execute multi-step tasks across all of these different systems.
And often with zero human intervention after that first prompt. The transition it's monumental. It really changes the entire skill set you need to leverage AI effectively.
How so?
Well, a chatbot is just an interface, right? It's interactive. An agent, though, is an operational entity. It could be your dedicated researcher, a compliance officer, or an automated sales pipeline.
So the real challenge for most people, especially if you don't spend your life writing code, is finding a clear, structured roadmap to actually build these systems.
Right, and that's exactly why we're doing this.
Which is why we are initiating a deep dive into the comprehensive architecture that's provided by the AI Agents Maker's Manual.
It's a fantastic resource, authored by Zahir Ahmad Mir.
And it's basically a promise, right? It promises to take you, the learner, from zero to building all types of AI agents in 4 weeks.
And with a huge emphasis on practical application, even for, the no-code builder. It's a complete curriculum distilled into an actionable playbook.
So our mission today is to extract that core architectural blueprint. We're going to identify the specific tools available.
And we mean the entire landscape, everything from proprietary powerhouses like OpenAI to the vast, flexible, open-source universe.
And then we'll synthesize the advanced concepts you need for deploying and scaling these agents safely and effectively.
We're giving you the ultimate shortcut, really. A guide to understanding the entire agent-building world, right down to the specific tools and workflows.
So the core question, the one that governs everything we're about to discuss, is this. What fundamentally makes an AI agent intelligent? And with that knowledge, how do we practically assemble one using the tools available today? Let's unpack this.
Okay, so before we even talk about construction, we have to solidify the vocabulary. The source material really emphasizes a crucial, necessary distinction that I think often gets blurred.
The difference between a simple chatbot, a digital assistant, and a true AI agent.
Exactly. So a chatbot is fundamentally conversational. It simulates dialogue. It has, memory limits, no real ability to act outside of that chat window.
And then a digital assistant like a Siri or an Alexa is a step up. It can execute simple, single-step tasks.
Right. Play a song, check the weather.
But always within a predefined, very limited domain. It's just following a script, essentially.
But the AI agent, that's an order of magnitude more sophisticated. It possesses true dynamic autonomy.
And its intelligence, you said, is derived from this PRA loop.
A PRA loop: perception, reasoning, and action. This loop defines the agent's operating cycle, and it's the ability to complete this cycle autonomously that grants it agent status.
Okay, let's break down that loop, because understanding it feels like the key to the whole architecture. So perception.
Perception is the input layer. It's the agent's eyes and ears.
So not just text.
Not at all. It could be text, an image, a complex JSON object streamed from a database, or even, sensor data in an industrial environment.
Yeah.
The quality of that input structure really determines the quality of the entire process.
Got it. Then you have reasoning, the brain.
The brain. It's the complex internal logic or decision-making flow, and it's all powered by the large language model. But critically, it's not just about deciding what steps to take.
It's more than that.
Much more. The reasoning component has to plan the execution, handle resource availability.
Manage time budgets, and deal with uncertainty if a tool fails or something.
Precisely. It's basically a project manager that's determining the optimal chain of actions to achieve that initial goal. That's where the real intelligence is.
And the final piece is action. This is the agent's hands, its ability to actually do things.
Do things in the real world, yeah. It can execute tasks using external tools or APIs. It might run a calculation with a Python interpreter, query a vector database for context.
Generate an image via an external API, or send a final report via email.
Exactly. Without the ability to call external functions, an LLM is purely intellectual. With action, it becomes operational.
Which is why the scope of application is so vast. We're talking about agents that can optimize your individual financial workflows.
Right, like summarizing quarterly earnings or filing expense reports.
All the way up to systems that can drive institutional change, like a tax compliance assistant or a legal precedent extractor used by, large organizations or even governments.
That's the destination. But the path there requires structure. And the source material lays out this fantastic, really comprehensive roadmap, the 10-step agent building framework.
And this ensures that even someone new to the concept doesn't fall into that trap of just unstructured, messy development.
Step 1 is the most deceptively simple one, and it's often where builders fail.
Which is?
Define the role and goal. If the agent's purpose is ambiguous, the whole reasoning flow will be muddled.
Leading to inconsistent actions, wasted effort.
You have to isolate its singular, measurable objective. Is it a research assistant? A coding validator? You have to be surgical with that definition.
Okay, so after you define the goal, step 2 is purely mechanical but foundational. Structure, inputs, and outputs.
Right. The agent operates best when the data is formalized. If your input is unstructured customer feedback, how does the agent parse that into usable data points?
And on the other end, if the output is a summary, does it need to be clean marked down for a human to read, or a machine-readable JSON object for another system?
Formalizing those schemas just guarantees consistency. It's a critical step.
Then we get to the technical backbone. Step 3, choose the right model.
This is about selecting the right LLM based on the task's complexity, the context window you need, and crucially, your budget.
Right, a simple classification agent doesn't need the most expensive top-of-the-line model.
Not at all. And then step 4, connect tools and APIs. This is the functional heart of the agent. This is what gives it capabilities via function calling, transforming it from a speaker into a doer.
And here's where that structure becomes so critical. Step 5 is design the reasoning flow.
This is where you, as the builder, map out the decision tree. It's the if-then-else logic.
So if the goal needs current information, use the web tool.
Right. And if that search fails, retry with different keywords before you give up. If it's successful, then proceed to the Python tool for analysis.
It seems like you could over-engineer this step pretty easily.
You can, and that's a risk.
Yeah.
But under-engineering it guarantees failure when you hit those edge cases.
And because these agents are interacting with real-world data and sometimes sensitive systems, step 6 addresses safety.
It has to. Add human-in-the-loop controls. For any high-stakes actions like making a financial transaction or publishing content, you must integrate checks and sign-offs.
Verification points.
Exactly. This prevents a catastrophic execution based on one single faulty piece of reasoning.
Then step 7, build memory and context. This highlights the limitations of the LLM itself, right? Persistent memory is necessary because that short-term working memory, the context window, is finite.
It's tiny in the grand scheme of things. If you want the agent to remember every interaction, every preference, every historical document from the last year,
You need an external system.
you do. And that usually means implementing vector databases. We'll get more into that.
Okay. And the final 3 steps are about deployment and maintenance.
Right. Deploy and test, which is step 8, moves the agent into a live operational environment. Step 9, automate and scale, prepares it for high-volume execution, maybe integrating it into your existing enterprise systems via webhooks.
And finally, step 10, monitor and improve continuously.
This is the one people forget. You have to ensure the agent's performance remains accurate, efficient, and consistent. You have to measure drift and hallucination over time. It's a full life cycle that demands constant oversight.
So now that we have that 10-step framework, let's zoom in on the core technologies that actually enable the reasoning and action parts. This is where we extract the technical how.
Okay. The ability for an LLM to take an instruction and turn it into a real-world action
Yeah.
that is dominated by function calling and API orchestration is
Right. Function calling is basically the communication protocol between the language model and external software.
that's a great way to put it.
I think we need to explain the mechanics here for our listener because it's such a crucial architectural difference. The LLM doesn't inherently know what tools are available, does it?
No, not at all. You, the builder, have to provide the LLM with a detailed description, a schema of the available external tools.
So you're giving it a menu.
A menu, exactly. This schema lists the function name, a human-readable description of what it does, and the required input parameters,
Yeah.
usually formatted as JSON.
So when I give a prompt, the LLM processes it and decides, based on its training and the menu I gave it, that, okay, the user wants to book a flight.
And then it translates your natural language request, book me a flight to London for tomorrow, into a machine-readable JSON object.
Which specifies the function, book flight, and the parameters destination, London, date, tomorrow.
Precisely. The LLM isn't executing the code itself. It's just reliably outputting a structured instruction for the code to execute.
And that JSON output format is absolutely critical because it guarantees reliable, machine-readable execution by the external system, Without that structure, the whole system just fails.
It falls apart. And this capability, combined with that dynamic plan that we talked about, is what allows for complex orchestration. The LLM calls Tool A, analyzes the result, and then generates the JSON schema for Tool B, creating a chain of actions.
And as we touched on, to support that chain, especially over long periods or with huge private documents, you need reliable memory. Which brings us to embeddings and vectors.
Right, an embedding is just. It's a high-dimensional numerical representation of abstract concepts or words or documents.
Okay, an analogy might help here.
Think of it like a librarian organizing a massive collection of books, but instead of organizing them alphabetically, they organize them by their meaning.
So in a traditional database, if I search for happy dog, the system won't find an article about joyful canine companionship unless those exact words are in it.
Correct. But with vector databases, the numerical representation of happy dog and the numerical representation of joyful canine companionship are placed very, very close to each other in this high-dimensional space.
I see. So the system understands the semantic relationship.
That's the power. Storing these embeddings in a vector database allows the agent to search vast external knowledge bases semantically. When you ask a question, the question itself is converted into an embedding.
And the database just retrieves the numerically closest chunks of information.
Instantly. This lets the agent pull the most relevant context, bypassing the entire costly process of trying to load full documents into the LLM's limited memory.
Okay, one last piece of the foundation. Let's revisit the actual decision-making inside the reasoning component. The source highlights something called hybrid reasoning.
Yes. We've sort of moved beyond purely predictive LLMs to agents that can combine two modes of thought.
And those are?
We're blending traditional rule-based logic, which is often called symbolic logic, with the predictive power of neural networks.
Okay, so symbolic logic provides the agent with deterministic rules, like safety constraints, legal compliance mandates, hard facts that can't be negotiated.
Exactly. The hard and fast rules. The neural network provides the creativity, the nuance, and the ability to handle ambiguity and complex patterns.
That sounds like a philosophical conflict waiting to happen. How does an agent using this hybrid reasoning manage the tension between the strict, rigid rules of symbolic logic and the fluid, creative interpretation of the neural network?
Well, that's the real challenge for the builder. You have to design a priority system.
A hierarchy.
A hierarchy, yes. Often, the symbolic rules act as a necessary guardrail. For example, if the neural network decides to generate a, let's say, controversial marketing slogan,
The symbolic layer, maybe a policy verifier tool, steps in.
it steps in and enforces a rule. No content may violate internal brand safety guidelines. The rule overrides the creativity. So the successful implementation isn't just combining the two, it's designing the conflict resolution layer, the part that decides whose input takes precedence in a critical moment.
With those foundations in place, let's talk about where the rubber meets the road. The toolkits. For many people, the journey starts inside a proprietary environment, specifically the ChatGPT ecosystem, using the OpenAI Agent Kit.
This environment excels because it integrates the core tools so seamlessly. It focuses on multi-tool reasoning and the automated creation of these complex chain of actions.
So the power isn't just in the individual tools, but in the agent's ability to fluidly transition between them without you having to manually stitch everything together with APIs.
Exactly. It's much more plug and play.
The source material gives us a detailed breakdown of the built-in tools, and I want to spend some time defining their unique purpose. Let's start with Canmore.
Okay, Canmore. It's defined as the long document workspace.
Why is that essential? Why can't the LLM just handle a long document?
Because if you feed a 500-page book or a multi-thousand-line legal contract into the standard LLM context window, you immediately hit the limits. The model just struggles to maintain context across all these disparate sections.
It forgets the beginning by the time it gets to the end.
Right. Canmore is specifically optimized for chunking, indexing, and cross-referencing that kind of massive unstructured text data. It's for deep, concentrated reading and synthesis.
So if I ask an agent using Canmore to compare Section 203 of a contract to an appendix on page 480, it can fluidly manage that cross-reference without losing the main narrative or running out of context tokens.
Precisely. Then we have automations. This is the task and reminder engine.
So this moves the agent from passive analysis to active workflow management.
It does. It lets the agent set recurring tasks, file documents automatically into cloud storage, or send reminders based on parsed deadlines from an email. It gives the agent a persistent organizational function that survives the end of the chat session.
The Python tool is one I think a lot of people recognize. The utility belt for data processing.
Absolutely. It lets the agent generate charts, handle file manipulation, and perform precise, reproducible calculations. It's essential for any kind of report, KPI tracking, or financial analysis where accuracy has to be guaranteed.
And for long-term user experience, the bio tool, you say this is indispensable.
I think it is. This handles persistent memory and user personalization. Every piece of information the agent needs to remember about you.
My preferred writing style, my project history, key team members.
All of it. It's stored here.
Hey.
This is what makes every future interaction feel deeply tailored, moving away from that generic, amnesiac LLM response.
And finally, the most critical tool for controlled, ethical deployment, the Guardian tool.
This is the specialized policy verifier. If an agent is designed to provide information on sensitive topics like financial advice, legal interpretation, or election news, this tool checks the generated output against a predefined set of safety and legal policy constraints before the final answer is delivered to you.
So it's a mandatory check within that reasoning flow.
It acts as that final symbolic check we talked about, the guardrail against the potentially riskier predictive output of the neural network.
The source uses the design example of the PackFiler AI tax assistant. Designing this in the OpenAI ecosystem would require meticulous architecture.
For sure. You're defining its role with effective system prompts, ensuring its data outputs are reliable using structured JSON schema.
And most importantly, chaining multiple tools.
Right. It would use the web tool for checking real-time tax law updates, the Python tool for calculating deductions, and almost certainly the Guardian tool to ensure compliance statements are included with every piece of advice it gives.
That detailed orchestration really showcases the power of the proprietary approach. But the AI landscape is massive. We have to explore the free and open source AI universe.
The Community Toolkit. It offers unparalleled flexibility and cost efficiency, especially for builders who really prioritize owning their stack.
For the no-code builder, the evolution of these no-code builders has been revolutionary. These platforms let you create visual pipelines, abstracting away all the code.
We're talking about specialist agent platforms like Agent GPT for quick prototyping,
Crew AI for complex multi-agent collaboration.
Auto GPT for defining long-running goals, and OpenDevin, which is focused on autonomous software development.
I think Crew AI needs a spotlight here. Its strength isn't just building one agent, but a team of specialized agents.
It's a fantastic concept. You can task one agent as the researcher, another as the editor, and a third as the publisher. The framework manages the flow of information between them, mimicking a human operational team.
So you're not trying to build one super agent that's good at everything.
No, you're building a team of specialists, which is usually a much better approach. And supporting these agents are the general workflow and automation tools. The authors call them Zapier-class automations.
Like Lovable AI, Flowise, Chatbot Kit, Make, and AAN.
These are the digital plumbing. They're essential for connecting your specialized agents, wherever they're built, to external systems like email, CRM, or data warehouses.
Flowise is particularly popular for building complex R-Rage pipelines visually.
It is. It uses a drag-and-drop interface, so you can literally see the data flow from the PDF file through the chunking node into the vector store and finally to the LLM. It really demystifies the entire architecture.
The source also provides a categorized map of functional tools, highlighting that specific tasks often need specialized open models.
Right. If your agent's core task is academic research, you need dedicated research agents. Tools like Consensus, Elicit, or Cite, they specialize in extracting facts and citations from peer-reviewed literature, which goes far beyond a general web search.
And if the agent needs to generate marketing collateral, the visual agents category comes into play. Canva for design templates.
And open-source models available via Leonardo or Playground AI for stable diffusion image generation. For multimedia, you're looking at Whisper for transcription, Cookie for voice synthesis, and Pika Labs for video creation.
The ultimate flexibility, though, lies in hybrid design.
This is the smart strategy. You combine the strengths of the proprietary cloud LLMs, which are often superior for complex abstract reasoning, with the specialized, flexible, and cost-effective capabilities of open-source tools.
All linked together via APIs and webhooks. The practical example provided perfectly illustrates this synergy. The book writing workflow with ChatGPT, Canva, and Notion. How does that orchestration work in practice?
So the ChatGPT agent is delegated the role requiring the most intellectual heavy lifting. It's handling the complex narrative structure, defining character arcs, creating the detailed chapter outline.
Okay, the high-level creative work.
Right. The output is structured and then passed via an API to Canva. Canva uses that output to automatically generate cover mockups and internal image designs, utilizing its specialized visual capabilities,
And then finally, the structured content is pushed into Notion.
which serves as the final organizational publishing layout tool. So it isn't one tool doing all the work. It's an intelligent, specialized team maximizing efficiency.
As we move into advanced architectures, we have to acknowledge that intelligence is no longer text-bound. Agents have to interact with the world in all its forms.
Which means building multimodal agents. This significantly expands their ability to perceive information.
The full spectrum of modalities is vast: text, image, audio, video.
And increasingly, real-time sensor data. I mean, think about agents monitoring factory floor temperature, seismic activity, or traffic flow. An agent that can see and hear the world can perform infinitely more complex tasks.
This capability breaks down into specific technical applications. For vision, that means core tools for optical character recognition, or OCR.
Right, extracting text from images. And object and scene recognition, which allows the agent to identify and categorize elements within a visual field.
For speech, seamless speech-to-text and text-to-speech pipelines, largely using highly optimized models like Whisper, are now standard.
And what's fascinating about video is the shift from simple analysis to complex creation. We're seeing agents that handle automatic captioning, precise summarization of long-form content.
And even editing tasks like automatically cutting out long pauses or merging segments based on narrative flow.
The incredible power here is that you don't need proprietary access to build this anymore. The open source community offers free multimodal stacks that are often world-class.
For vision and OCR, you can leverage robust tools like Tesseract and Paddle OCR.
And for image generation, the source highlights Stable Diffusion. But it's important to understand the interfaces. You can run it through simplified GUIs like Automatic 1111.
Or use the incredibly powerful but more complex node-based workflow editor, Comfy UI.
Which gives builders precise control over every single step of the image generation process. And Invoke AI sits somewhere in the middle, offering a more collaborative environment.
We also have to mention the growing trend of running local LLMs.
For privacy and low latency, platforms like Llama and LM Studio support models like Mistral, Llama 3, and Phi. This allows sophisticated reasoning to happen entirely on your local machine.
And uniting all this complex, unstructured multimodal data are the vector DBs we talked about, FAIs, Chroma, Milvus, Weaviate, which are the necessary memory structure.
The complexity of these systems is best illustrated through the case studies. Let's dissect the legal doc camera agent.
Okay.
This is a perfect example of a workflow that solves a real-world, time-intensive problem. A lawyer or paralegal takes a phone photo of a physical document.
That image immediately triggers the pipeline.
It's sent through an OCR tool, maybe Tesseract, to generate the text. That extracted text is then fed to an LLM, which is often running a specific legal RAD pipeline.
And it's tasked with summary analysis, maybe flagging non-compliant clauses or extracting precedent citation numbers.
The value is the immediate speed of intake and initial triage. It eliminates hours of manual transcription and reading.
And the second example, the podcast pipeline agent, is even more ambitious. It's a multi-format automation.
This agent manages content end-to-end. The raw audio is uploaded, automatically run through a model like Whisper for transcription.
The resulting text is then used by the LLM to generate show notes, bullet points, marketing copy.
Those notes are then passed to an image generation tool to create a promotional image for social media. Finally, the agent handles the post-distribution across multiple platforms.
It's a cohesive automation system that turns raw media into finished, optimized content with minimal human interaction.
Moving on, we need to address the crucial architectural layer that enables specialized knowledge. Retrieval Augmented Generation, or RAGE.
This is the key link between an agent and a private, grounded knowledge base. Your company's proprietary data, internal research, legal archives.
RAGs is essential because it's how agents move beyond the generalist knowledge of their training data. It allows the agent to be deeply specialized and factually accurate on specific internal information.
And it dramatically minimizes the chance of hallucination by forcing the model to refer to concrete sources.
Exactly.
So let's break down the technical dance of the RAG pipeline. It's a multi-step process that builders have to manage carefully. First up, chunking.
Chunking is just the process of breaking down large documents, say a 200-page policy manual, into smaller, manageable segments, or chunks.
And the strategy here is crucial, right? If the chunks are too large, the LLM gets too much extraneous information.
And if they're too small, they lose critical context. Good chunking strategies often involve overlap, where the beginning of one chunk repeats the end of the previous one to ensure continuity.
Once chunked, we generate embeddings for those segments and place them into the vector database. When a user asks a question, the agent searches that vector space, retrieving the chunks that are numerically closest to the question's meaning.
But retrieval is not the final step. Then we enter the re-ranking phase.
Why is that needed?
Just because a chunk is semantically similar doesn't mean it's the most relevant. Re-ranking uses a separate, often smaller and faster model to score the retrieved chunks for actual relevance and context. It filters out potentially misleading results before feeding the final, highest quality information to the LLM.
And all this complexity is necessary to maximize grounding quality and ensure citations are robust.
Right. If the agent can accurately cite the exact page number or section of the internal document it used to formulate its answer, the risk of hallucination just plummets. This advanced evaluation of grounding quality is non-negotiable when connecting an agent to sensitive custom knowledge bases.
This combination of ARID and function calling opens up this incredible array of diverse applications outlined in the source.
We see legal AI agents that function as an argument and ratio extractor, pulling key reasoning from judicial decisions.
Healthcare agents acting as diagnostic explainers for patients.
And media agents automating entire podcast and YouTube production lines.
And for the entrepreneurial learner, the manual highlights practical monetization models. This isn't just about building for fun, it's about business.
Strategies include selling AI services directly, licensing a proprietary agent designed to enterprises, franchising an agent's operational model.
And, of course, standard subscription and freemium strategies for wider consumer release.
We now move to, I think, the most serious section of our deep dive, the necessary topics of safety, ethics, and governance. The reliability and longevity of any agent depend on its ability to operate securely and compliantly.
We have to start with the legal and ethical frameworks. This is the foundational compliance layer.
As a builder, you must consider IP rights associated with the data used for RAG, strict data privacy requirements, and specific regulatory acts impacting your jurisdiction.
Whether you're operating in the US, the EU, with the AI Act, or elsewhere, an agent deployed without this understanding is a massive liability.
And from a practical defense standpoint, you need rigorous security engineering. The primary threat is prompt injection.
This is where malicious actors try to override the agent's core instructions, the system prompt, by inserting cleverly worded user input.
Defenses against this require techniques like input scrubbing, sandboxing the LLM environment so it can't access unauthorized external systems.
And meticulous secrets and token management to protect API keys.
And a crucial part of testing security is red teaming.
This isn't just checking if the agent works, it's actively, offensively testing the agent's vulnerabilities and limits. You're simulating a malicious attack to ensure robustness.
If you don't try to break your agent, someone else will.
Beyond security, there's evaluation and optimization. How do we objectively measure an agent's success, especially when we're dealing with nuanced language generation?
We rely on standardized natural language processing metrics. The source mentions where you are, BLU, and Rouge.
Okay, this is critical. We need to define these. Where?
Where stands for word error rate. It's essential for agents that perform transcription tasks, like our podcast pipeline agent. It measures how many words in the agent's output transcription differ from the ground truth.
Yeah.
It's like a typo counter, but for speech to text.
Got it. And BLU and Rouge.
They're metrics for assessing generated text quality. BLU, which is Bilingual Evaluation Understudy, is commonly used to measure the similarity between the agent's generated text, like a summary or translation, and a set of human-written reference text. It focuses on precision.
And Rouge is typically for summary quality.
Right. It's recall-oriented gisting evaluation. It measures the overlap in words or n-grams between the agent's summary and the reference summary, focusing on recall, making sure all the necessary points were covered.
Using these metrics allows a builder to move beyond that subjective "it looks good" testing to objective, measurable performance grading.
And finally, we have to address the practical business aspect, cost optimization. Advanced agents can be really expensive to run.
So builders have to master strategies, like careful token budgeting, ensuring the agent doesn't use massive, high-cost models for simple tasks.
They should also implement caching, This prevents the agent from recalculating the same result multiple times. If the agent answers the same question about tax law twice in one day.
It should pull the cached verified answer instead of running the entire RAG pipeline and LLM query again.
Exactly. And furthermore, using those smaller, highly efficient local models for simple tool tasks saves significant money compared to relying on the largest, most expensive cloud model for every single step.
We have journeyed from the conceptual definition of intelligence with the PRA loop through the 10-step assembly process and right into the complex world of hybrid, multimodal, and ARG architectures. For you, the learner, the key takeaways should be structured and actionable.
I think so. Agent building is accessible and it's structured. It doesn't require a deep coding background anymore, thanks to the explosion of no-code tools like Flowise and Crew AI.
But that accessibility demands diligence. You still have to strategically implement memory via RA and strictly adhere to those safety and ethics frameworks to ensure you get a reliable, high-quality output.
And the source material is designed to provide that immediate scaffolding. We know from the outline there are appendices with prompt engineering workbooks, specific legal policy references for compliance, and a comprehensive free tools directory. The resources are there.
This whole shift is more than just a technological upgrade, though. It fundamentally redefines organizational structure.
And that brings us to our final provocative thought, looking ahead to the future of work with AI agents.
The ultimate ambition for builders is not simply creating individual tools, but architecting what the source material describes as autonomous enterprises.
These are systems where agents handle complex, end-to-end business processes, from client intake all the way to service delivery, with minimal human oversight.
So if the enterprise becomes autonomous, the necessary perspective for human workers has to change.
It has to. We need to move from executing tasks to supervising strategy. We must define the optimal human plus AI collaboration model.
How humans supervise and guide these agents, intervening only at critical decision points.
And how agents provide the necessary transparency for us to audit their logic and their reasoning.
The agent maker is not just a software builder anymore. They are an organizational designer, defining the new dynamics of the workplace.
The knowledge we've covered today is really the necessary foundation for anyone looking to step into that critical amplifying role. This is the era where structured intelligence meets autonomy, and the rules of work are being rewritten right now.